So my name is Björn Olofsson and I'm an associate professor here at the Department of Automatic Control. And I do research and teaching within robotics.
I'm Yannis Karagianidis and I'm associate professor in the Department of Automatic Control. I work with robot control and I have a bit more focus on tasks that involve interaction with robot and other objects or actors of its environment. In our lab we have different types of robots. We have industrial robots that have been traditionally used as well in industrial cells. But we have as well modern collaborative robots that can work in the vicinity of human because they're inherently safe.
Now we are here with a robot, a legged robot. It's called Spot. And this robot we are using for various kind of robotics research and teaching activities.
Spot can be used in environments that are very difficult for humans to be, even toxic environments. So this means that in the future we can use such type of robots going to unstructured and dangerous for human environments, and this will be beneficial for the society.
And then here in this lab here we have the so-called parallel kinematic machine or robot. And they are constructed a bit differently compared to conventional robot arms. Thanks to these parallel bars, it is a bit like when you're playing volleyball. I mean, you're using two of your hands and then you can get more force. So for example, they could be used to drill, and it can also be used in milling tasks, for example, in industry.
Robotics is an inherently multidisciplinary area. It combines mechanical engineering, electrical engineering, computer science, and nowadays with artificial intelligence, there are also other questions that involve other sciences, like more human sciences. So in our case, in automatic control, we are providing the glue, in fact, in order to combine the different parts from mechanical engineering, computer science, and electrical engineering, because in a way, automatic control is the motive force, how you get the sensor measurements, how you interpret them, and then send appropriate commands so that you can move the robot.
A lot of the research that we do here in the lab, it's actually to extend the functionality of the robot and let it do tasks that were previously not possible to do with the robot. So it's not only about developing new robot designs and new types of robots, but it's also to let the robots that we already have do new tasks that weren't possible before. And that we can solve with using automatic control.
If you have experienced engineers, then they can program the robot using their computers. But if you imagine a scenario that the robot is cooperating with humans that are not that experienced when it comes to engineering, then you should find ways that are intuitive for the humans to program them. One of them is programming by demonstration. In this case, a human worker or an operator can just demonstrate the task to the robot. The robot can capture this sequence of actions and then try to repeat them.
So here in the robotics lab, we do robotics research together with both academic and industrial partners. And when it comes to industrial partners, we do joint research both with robot manufacturers and also companies that would like to use robots in novel and innovative ways.
Right now we see robots working in industrial environment as also in our labs in academia. So what we envision is to see general purpose robots work in more general environments and make our life easier.
Yeah, so to solve different robotics challenges, for example, when they are interacting with humans, automatic control will be an essential component